orthogonal, not orthonormal. I always repeat that. So I already got obtained the volume, the differential, okay, the element of volume, and the element of length. Okay, I just multiply this, the scalar. Okay, this is dr square, r square, the phi square, and this is I square sine square of phi d theta square. Now, I had, okay, many videos ahead. We're going to talk when Einstein field equations. We're going to study the Schwarzschild model. You see, there, I will remind you just to remember this relation over here. Okay, it's very important. So, but there we are working the R4. Okay, so in the Einstein field equations, there will appear, okay, a fourth coordinate. Okay, we're gonna see this. Okay, but this now again is extrinsic geometry. Okay, which can be used when you study engineering calculus. Okay, this is the subject which is directly applied to the calculus, okay, advanced calculus. Okay, that's it. So we derive elements of volume and elements of the length in R3. Now always think about this figure over here, okay? Because again, C1 will be capital R, okay? Capital R. C2 is phi, and C3 is theta, okay? So the previous video we draw a figure showing the polar coordinate, the radius coordinate, the polar coordinate, and the azimuth coordinate. Okay, and also in part 3, lecture 4, you can see the spherical geometry with these angles, okay, which are the spherical coordinates. That's it. Next, we're going to talk about the element of the area, okay, of this figure over here, which is the same as we draw from the part 3, lecture 4. Okay, so there will be the element with R, phi, and theta. Okay, that's it.